Today we're going to be continuing to look at the binomial expansion, introducing factorial and choose. Step 1. Recapping what we learned last lesson. Step 2. An explanation of factorial. Step 3. Using factorial and choose. Step 4. Solving binomial expansions using NCR. Last time, when we looked at expanding a binomial, like 2 plus 3x to the power of 7, we used Pascal's triangle to find the binomial coefficients and then expanded each value in the brackets individually to find our answer. But what about 2 plus 3x to the 25? Or some other big power? If we were to write out Pascal's triangle for this, it would take us a long time, and there would be a much higher potential for a mistake. There must be a better way. Well, actually there is, and that's why we're going to look at factorial and choose. So, what is factorial? How do we calculate it, and how do we use it? Well, first of all, the factorial of a number is written as n exclamation mark, where n is a whole positive number. So the factorial of 5 would be written like this, 5 exclamation mark. So what does it mean? All it means is a number multiplied by all the numbers that precede it, down to 1. So here, 5 factorial is 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which gives us the answer 120. And 8 factorial gives us the answer 40,320. So now we know how to calculate the factorial of a number. But what's the point of this? What does it actually do? Well, n factorial is the number of ways of arranging n objects in a line. Let's examine this idea further. Let's look at this example. Suppose you had 4 letters, A, B, C and D, and wanted to arrange them in a line to form a 4-letter word. For example, ACBD or DBAC. There are 4 choices for the first letter. There are then 3 choices left for the second letter. There are then 2 choices left for the third letter. Then there is only 1 choice left for the last letter. Therefore, there are 4 multiplied by 3 multiplied by 2 multiplied by 1, which is the same as 4 factorial, which means that there are 24 possible combinations. Take a look at your calculator. You should be able to see a button marked x factorial. We can use this from now on, instead of multiplying out all the numbers one by one. Now let's take a look at choose. What if I want to choose 3 items from a list of 10? It doesn't matter which 3 items or the order in which I choose them. I just want to know how many different ways there are of choosing 3 items. To do this, I can use a formula called NCR. It may look complicated at first, but all you need to use are the values for the total number of items and the number of items that you want to choose. In this example, n equals 10 and r equals 3. If you substitute these values into the formula, you obtain the answer 120. This means that there are 120 different ways of choosing 3 items out of 10. But more importantly, this has also generated the binomial coefficient of the 4th row of an expansion to the power of 10. On your calculator, you should be able to find the NCR button. This will enable us to calculate the binomial coefficients much quicker. If we take a look at the previous example, we wanted to find the value of 10C3. So, on your calculator, write the number 10, then press the NCR button, then write the number 3. Then finally press the equal button. You should now see the answer 120 on your calculator display. When we look at Pascal's triangle, you can see that the equivalent can be written in the form of NCR, where the top numbers in the brackets are the same as the row number, and the bottom numbers in the brackets increase up to the top number. Next, we will apply this to an example question. In this example, we're asked to find the first 5 terms in ascending powers of x of the binomial expansion 2 plus 3x to the power of 7. First, we need to write out NCR for each row, Remember, we only need the first 5 rows. Then we take the first part inside the brackets and put that value to the power of 7, all the way down to 3. Next we take the second part inside the brackets and put that to the power of 0, all the way up to 4. Now use your calculator to find the binomial coefficient and multiply through the rows. Once you have done this for all the rows, we can put everything together for our final answer. In this example, we are asked to find the first 5 terms in descending powers of x of the binomial expansion of 2 minus 3x to the power of 12. Notice that in this question we need to find the terms in descending order. So far we've only been finding terms in ascending order. So what's the difference? Well, nothing really. All it means is that we're going to find the terms from the other direction. Let's write down the binomial coefficients first. Do you notice that nothing has changed here? The reason why is because the binomial coefficients are symmetrical, so it doesn't matter which way around we write them. Next, let's take the first part of the inside of the brackets and put that value to the power of 0 all the way up to 4. This is our first change. Usually we'd start at the power of 12 and go down, but because we want descending and not ascending terms, we are going in the opposite direction. Next we take the second part inside the brackets and put that to the power of 12 and go down to 8. Again, you should notice that usually we'd start at the power of 0 and go up, but because we want descending and not ascending terms, once again we're going to go in the opposite direction. Now use your calculator to find the binomial coefficient and multiply through the row. Once you've done this for all the rows, we can put everything together for our final answer. Thanks for watching, and remember that there are lots more videos just like this one on Mr. Gregory Online.